Hello friends, welcome to my channel Raji CS Revision and Notes. So today again we'll solve a problem in operating system. So problem is consider three processes P1, P2, P3 as shown in table. So they given three processes and arrival time and the time unit required, which is the burst time. So the completion order of the three processes under FCFS and RR2, that is round robin, the time quantum of two time units is what. So they given the options. So let us solve this problem. First we have to solve using FCFS, first come first serve, and then next round robin method. Let us see how to solve the problem. Now first let us solve this problem using FCFS or first come first serve method. Okay, so they given the process P1, P2, P3. Arrival time is 0, 1 and 3. Burst time is 5, 7 and 4. So what they given. So we have to find out these values. First for that we'll draw the bar chart. So here at time 0, so what process will be there? So time 0 only P1 process will be there. So P1. So P1 has burst time of 5. So it is a first come first serve. So it is a non-preemptive one. So what happens will be full burst time it will be completed. The task will be possibly completed fully. So it will value for 5 time units. So from 0 to 5 time units, P1 process P1 is executed. Next process comes as P2, which has a level time of 1. So P2 is in the CPU. So it has performs the task in burst time of 7. So with 5 to plus 7, which is 12. So it does the process till 12. Next processes that comes in is 3 P3. So P3 comes in. So P3 comes, it has a burst time of 4. So it will be 12 plus 4, which is 16. Hence the completion time is, so what is completion time of P1? Completion of P1 is 5. Completion time of P2 is 12. Completion time of P3 is 16. So what is the turnaround time? So turnaround time is calculated by completion time minus the arrival time. So 5 minus 0 is 5. 12 minus 1 is 11. And 16 minus 3 is 13. Now waiting time. So how is waiting time is calculated? So waiting time is turnaround time minus burst time. So turnaround time minus burst time. So 5 minus 5 is 0. 11 minus 7 is 4. 13 minus 4 is 9. So this is the waiting time. So you can also calculate what is the response time. So how will you calculate response time? So response time is first when the process gets a chance in the CPU. So if we see the process P1, you have to find this value, that is left side of the process, that is this is the first response time in the CPU, so 0. But it must apply the arrival time. Okay, so here it is after arrived, it has gone into the CPU. So here it is 0 minus 0, that is response time is 0. For process P2, see, its first causes CPU at 5 and its arrival time is what? It is 1. So 5 minus 1, that is 4. Next for P3, it is got in the CPU at time 12 and its arrival time is 3. So 12 minus 3, that is 9. Okay, so this is how the response time is calculated. So here the order of completion will be P1, P2 and P3. So normally in first come first serve, the first process will be executed first. So even without performing these operations also, we can write the order as P1, P2, P3. But just for understanding of all the process and what are the terms I have done the process. Okay, so even if they ask the average turnaround time, average waiting time or average response time, we can calculate. See, the average turnaround time will be, see, 5 plus 1, 6, 6 plus 3, 9 and 29. So 29 by 3, which is the average turnaround time. So waiting time will be 13 by 3 and response time also 13 by 3. So the average turnaround time will be 9.66 and waiting time will be 4.33 and response time will also be 4.33. So now let us see the round robin method. As you know, in round robin method we have to use a ready queue. Okay, so in ready queue we will write what are the processes waiting in the queue. So the first, see there are 3 processes at time 0. So process 1 will be ready. So P1 goes to the CPU. So you can write the timeline as P1. Okay. Next, it continues for what? So the given as RR2 means 2 time slots. So 2 time units. So performance for 2 time units. And here I replace the burst time. Okay. Here it has taken 2 time slots. So it will be 3. Next, when time is 2, so process P2 would have arrived, and also we have to write P1 also in the ready queue. But first which will write? We'll write only the process which has arrived. Okay, so the process which has arrived, because it has arrived at time 1 itself. So this P1 performs till time 2, but process P2 has arrived at time 1. So here it will be ready P2. Okay, and then we have tried the P1, the ready queue. So this is the format for all the process from the ready queue. Even if the time is, even if the arrival time is 2, and if this completes in 2, first we have to write the process which is coming in the that is which is scheduled, that is first which is coming, we have to write that is P2, and then only the process which has finished performing and is again has to be written next. Okay, first we write P2 and then we have to write the P1. So this is how the round robin works. Hence now you write P2. We finished writing P1, so P1 is like of P2. So when you have P2, P2 has a burst time of 7, but here we can have only 2 time units. So replace this by 5 and we given 2 time slots. Next, when this pose completes, its time is 4. By time 4, what will have happened? Pose P3 would also have arrived. So what we'll do? We have to write P3. First, you have to write P3 which has arrived, and then we have to write the remaining of the P2. So P2 also have some process to finish. It has burst time of remaining 5. So again we have to write P2. So this is way we will write the values. So in the PDQ we have to write P3 then P2. So next we have completed P2. So time is 4, then we take the P1 value. So P1 process here again, it is at burst time of 3 is remaining. So but only 2 is the time quanta. So you have to write, you take 2 and then again we'll have 1. So it is remaining. So how, what you'll do? You have to write the P1 value which is still remaining. So you write P1 value in the ready queue. So after this time slot is completed, that is arrival time is completed, for further processes, when you write in the chart, that is in the timeline, you have to write the process. When if it is unfinished, you immediately write in the ready queue. So that way will not have any mistakes. So we have written P1. So next we have taken P2, P1, P2 and P1. So next we have taken P3. So I have taken P3. P3 is arrived here and it has burst of 4. So I will give 2 time slots. So it will be 2. Next, again you see that P3 is not completed yet. So again what I'll do, I'll write P3 here in the ready queue as it is not finished. So I've completed P3. So next my ready queue is P2. So P2 I take, P2 is having a first time 5 still, so only 2 I can give. So if I give 2, it is 3, so it is 10. So again I have some remaining in P2, so what I'll do, I write it in the ready queue as P2. Now my P2 is completed. Next I go to P1. So P1 I write. P1 has a burst time of what? It is burst time of 1 only. So what I'll do, I'll complete it. Okay, so I would have a burst time of 1 only. So I'll write it as 11. In 1 it is completed. So P1 is completed. So I did not write anything in the ready queue. So P1 is completed. Now P3. So P3. So P3 has a burst time required 2. So I will give 2 time. So 11 plus 2 is 13. So P3 is completed also. So again I did not write in the ready queue. So next is P2. So P2 has a first time is 3, but I can write as 2, that is 15. Then again, since no other process is remaining, we can write given one more time slot, that is 1. So is 2 and 0. So again it comes 15 and then 16. Hence we have completed all the process in the ready queue. Now it is finished and burst time everything is completed. So now we can write the completion time. So how will write the completion time? When we want to write completion time, we have to check the each of any process. See P1 is last, it is completed in at time 11. So 11 is the completion time for P1. Next P2. P2 is completed in 16. So completion time of P2 is 16. Then completion time of P3. P3 is completed in 13. So 13 is the completion time for P3. So this is the order. So the order of completion is first is P1, next P3, and then finally P2. So can calculate the turnaround time. So turnaround time is what? Completion time minus arrival time. So 11 minus 0, that is 11. 16 minus 1, that is 15. 13 minus 3, that is 10. So what is the waiting time? That is turnaround time minus burst time. So 11 minus 5, that is 6. 15 minus 7, that is 8. And 10 minus 4, that is 6. So what will be the response time? So response time will calculate when first it gets the response from the CPU. So if we take process P1, so what is the response time? First it is in the CPU at time 0 itself. So 0 minus 0, that is 0. So take P2, the first response time is 2. So 2 is starting. So 2 minus available time of P2 is 1. So it is 2 minus 1, that is 1. Next P3. So P3 first, when it got the CPU, got at 6. So 6 minus its arrival time is 3. So 6 minus 3, that is 3. Okay. So this is where you calculate the values for the turnaround time, waiting time, and response time. Next we can, if you want to find the average values, you have to add this and divide by 3 number of process. So the values will be, the average turnaround time will be 12, the average waiting time will be 6.66, and average turnaround time, response time is 1.33. So here the order of completion is P1, P3 and P2. Hence the solution to this problem is the third option, that is first come first serve. The order is P1, P2, P3, and round robin 2 is P1, P3 and P2. So this is the current answer. Okay friends, I hope so it's clear to you. Please like, share and comment. Subscribe to my channel RGCS Revision and Notes for more videos like this. Thank you.